All right, well, as you can see, we're having a great time here in statistics. We're going to do some AP multiple choice review questions before our test over all this on Thursday. Okay? So let's start with number one. Number one doesn't really have a whole lot of information. Wow, talking, good start. You have probability of some event D is 0.6, and it gives you the probability of event D and E occurring is 0.18. Now, it does give you something important. It tells you that they are independent. Okay? Now, this is going back all the way to chapter 14, where the probability of D and E is equal to the probability of D times the probability of E. Why am I allowed to do this? Because they're independent. All right, so this becomes an algebra problem. You already know the probability of both of them happening is 0.18. You know the probability of D happening is 0.6. So then you can use algebra to find probability of E. Bless you. So what is the probability of E? I think we all know 6 times what is 18? 0.3. Okay, so it says which of the following is true, and right away I see probability of E for A and B, but do those equal 0.3? No, so A and B are wrong, because it doesn't say that it's equal to 0.3. Be careful, we have more work to do. So, the other work I'm going to do is the probability of D or E. Does anybody remember this formula? You add them. Very good, Jarvis. So you have D and E. Now here's the thing, Jarvis. Don't get too carried away. I have to do something else because it did not say that they were disjoint. Right? Remember, they can occur at the same time. So what do I have to do at the end here because they are not disjoint? Who remembers? You have to subtract the probability that they're both occurring. D and E. Now again, we have three of them we know, and one we don't. This becomes algebra. I don't know the probability of D or E. That's what I'm solving for. So we know D is 0.6. E is 0.3 minus 0.18. And if you get that, .72. So the answer is actually going to be D. The probability of D or E is 0.72. Now that required a lot of work for that little tiny problem. Now, you might be a little worried because, like Mr. Frederick, I do not know those formulas. Fair enough. You're going to get a formula sheet on Thursday, which will include those formulas.
Thank you.
You're welcome.
I don't understand the format on the book.
Format on the book. There is no book.
No, like on the chapter reading guides, when they
Yeah.
do this,
Uh-huh.
it's like,
Oh, do they do the symbols?
yeah.
Yeah, so this one here is and this one is or. Like you, I don't use the symbols. I just like words. Okay, that's why I don't use emojis.
So because they're not disjoint, you had to do that step?
Correct. If it had said that they were disjoint, then I would not need to subtract out the probability that they're both happening, because they can't happen. It would be 0.
But you would have to do the or, both the and the or.
Well, in this problem, because it's asking you for like different things in the answers, you kind of had to do all of it, right? If this had been 0.3, I'm done. Right? They could have had the first answer say 0.3. I'd be like, great, I did it. But because none of those are right, then I went to the next one, which is the only other option here with D and E by itself, and is or. That's the only other one we can find. Okay. Okay, let's do number 2. Oh, number 2. Whew. Okay. Now, number 2 gives you 2 random variables, x and y. But this problem is a little tricky because x and y does not take into account the points that they're awarding. Okay? So x and y is just giving you the mean and the standard deviation for the number of cards they move into the right spot, and then y is how many minutes it took them to finish the game. All right, but the first 2 sentences tells you they receive points for moving the cards in the right spot, and they get penalized if they take more time. Okay? So the first thing I did was I took my means of 9.5 and 5.4, and I multiplied them by 5. Nope, not both by 5. Sorry. Just the 9.5 by 5 and the 5.4 by 10. I apologize. Yes, so you get 5 points for the random variable x. That's when they're moving the cards in the right spot. And they get penalized 10 points for taking more time. Okay? And it says here the expected value. So when they use that word penalized, where is that? Right here, penalized. That to me says I have to subtract those. They're taking it away. Okay, so in your calculator, you could do that. 5 times 9.5 minus 10 times 5.4, and you would be able to eliminate a few answers. So who got the expected value? Great. So you see right away, we're going to get rid of C, D, and E. Hello, welcome. Who were you with?
I was with the nurse and then to Mr.
Okay, all right. We're going over. Stop it, Charlie. We're going over the Unit 4 multiple choice questions. Yes, that's on recording now. Okay. Are there any questions so far? I haven't answered it fully, but I at least have eliminated to make it 50-50. Okay, now here's where it gets really tricky. Okay? Because what most students do is do the same thing, but for the standard deviation. So they take this number, multiply by 5, this number times 10, and they subtract. And you guys know that that's going to be wrong, right? Because we have to do variances at... Now, I'm actually going to go to notes from chapter 16, because I have it all here. Okay, I want to go to a slide to show you what I'm about to do. Where are you? There you are. Okay, so what we just did was this right here. The expected value of the points was we multiplied by 5 and by 10. Okay, but look at the variance when we do this. Am I going to do 5 and 10? Now, what am I going to do? 25 and 100. And I'm also multiplying that by the variance. So there's going to be a lot going on here. Let's see if you can understand it. Okay, so the first one is random variable x. That one is going to be 5 squared times 12.9 squared. Okay, please ask if you don't know why I did that. So I did, remember it's 5 points, but I have to square it because I'm dealing with variance. And then I did the standard deviation, but I have to square that because I'm dealing with variance. So I'm going to do the same thing for y.
How do you know when you're dealing with variance?
Because I'm always going, when it says standard deviation of random variables, you always know you're going to do variances at. Always.
Other times you just add them.
I've never just added the standard deviations. If you call me on tape, show me, because I should never do that. It's always variances at. Okay, so does everyone see why I did the 10 now? I'm using the next variable, which is penalized the 10 points. So 10 squared And then the 1.1 also needs to be squared as well. So if you get those two numbers, whatever they are, you're going to do what with them? You're going to, at first, you're going to add them. And then square root. And that'll give you your answer. So, yeah.
What's the point of squaring them and then taking the square root?
It's not going to be the same if you do just like work with standard deviations. It's different. Because technically, the variability has to actually get bigger than what you would think. If you remember the lemonade example, right? If you just start using standard deviations, you won't get the correct variability. Okay, so that's why you have to do the variances at. All right, so there's a lot of button pushing happening, hopefully, with 4 students. Did you get an answer yet?
65.4.
You did it, and look, that's B.
So every time you're dealing with
Random variables,
deviation or like variable,
you're thinking variances at. It was just the second question.
Variance is the standard deviation.
Variance is the standard deviation squared. Always.
always adding first before
Yes, the very last thing you should ever do is the square root. All right, and you notice that I know I wrote addition here, but really what did I do with the expected values? I subtracted, but did I do subtraction with the variances? No, because they'll always add. So I bet if you had subtracted, you would have gotten this number. Right, I bet. So these are numbers. I don't know them because you can do it. And then you add them because these are the variances. And then you add them and take the square root. Okay? So I know the work is not fully complete. At the very end. Okay, let's go to number 3. Okay, number 3. According to this report for vets in the U.S., we have the likelihood that a household owns a dog is 0.365. For a cat, it's 0.304. What is the probability that a household has a dog or a cat? So we have dog or cat. Well, guys, let's write down that formula. We just did it. It's dog plus cat minus dog and cat. Because let's ask ourselves this question. Is owning a dog and owning a cat, are those disjoint? If I own a dog, then I can't own a cat. If I own a cat, then I can't own a dog. Well, I'm sure there's at least one of you that has a dog and a cat. Anyone? No one. No one has a dog and a cat in this room? Oh, man, they're disjoint. You have a dog and a cat? I just have a dog. I have a dog and a Catherine. Anyway, I think we would all agree that that was pretty good. I should stop right now. I think we all agree that owning a dog and a cat are not disjoint. You can have both. And so, guys, to find this answer, I need dog. Do I have it? Yes. I have cat. But do I have dog and cat? No. And if I wanted to use the formula from number 1 and multiply dog and cat, I'd have to assume that they're independent. Do you think that owning a dog and owning a cat are independent? I actually think that if you own a dog, you're less likely to own a cat. That's what I think.
Fully independent, but it's like a small bit.
There's independent or not. There's not like partially.
There's like a rule.
There's a rule. But what I'm trying to say is we don't have enough information to do this.
Oh.
wait, why?
Oh, wow.
Because
okay.
we need this one.
We don't have.
And we don't have it.
So we
The end?
We don't have n.
If they were to say.
Because it doesn't say it's independent.
Because it doesn't mention independence, and I don't think they're independent. You think they're independent. You think that owning a dog, owning a cat is independent. Okay.
So if it doesn't mention.
So if you agree with that, if you think they're independent, then you should be multiplying 0.365 times 0.304, and that's going to go here. And then you would do the whole thing.
So I would have been wrong.
You would have been wrong. But you stuck to your beliefs.
But I was
Oh, because this is they don't care what you think. They care what they think, and they think you're wrong.
Are
What do
you?
you think?
Well, this is not going to be the problem on the test, so I agree with you. Good job. What? Correct. It doesn't say they're independent. When I think about it, I don't think they're independent. It doesn't say they're independent, so I can't just multiply them. I can't just do this to get and. It does to be able to. That's what number one said. Remember, number
It
one.
doesn't have to say anything about disjoint, but it has to say.
Disjoint. The reason you don't have to say disjoint. I mean, I think we're all humans, and we all know there are families out there that have both animals. I don't think we need. I think we're going down a rabbit hole that's not going to be a problem tomorrow or on Thursday. Let's move on. We've clearly lost it. We are now in middle school. I'm going to do them all. If we focus, I can get through them all. Number 4. We ready to keep going? It's a farting noise. You okay? No, you're not? Okay, you know, flatulence humor is always good. Always good. Okay. What is the probability that the number of times that Luke hits the inner ring of the target out of the 5 attempts is less than the mean of this random variable? Well, the first thing I see there when I read that question is it wants to know the mean of this random variable. In order to do this problem, I need that. So that's the same thing as the expected value, and hopefully by now you know what to do. You take all of the possible number of attempts, 0 through 5, and you multiply them by their respective probabilities. You add those together. Now you can use the yellow calculator. Remember list 1. You could put 0, 1, 2, 3, 4, 5. And then multiple choice, man. I'm not great at it. And then list 2, you put the probabilities, and that's your frequency. Remember the frequency from there? Yeah, free response. Yes.
So we had to show them.
Yes, free response questions. You're good. That's tomorrow.
Wait. Oh, I say, hold on. I thought it was Thursday.
22nd or full? Full timeout. What's the problem? Did anyone find it? Yurette's doing it. It looks like Catherine's doing it. Maybe some other students are trying. Should I show the work of like what you should be doing? So 0 times 0.000. What's up? Would I be doing any of this? No, I wouldn't do any of this. Which one? Kira? Okay. I don't, Guillermo, I don't show any work, like I just show the work I need, or personally I need for multiple choice. First the farting sounds, now this. Oh, is that good? It happens, right? It's got to come out some way.
It's going to come out somewhere.
It does. I didn't know we had any ducks back there. You stepped on a duck.
When you do this, do you put 1?
0, yeah, you put 0, 1 variable statistics. Because there's only, Catherine has a good question, guys. She's using the calculator, and she's at the 1 variable stats and 2 variable stats. There's only 1 variable here. right? There's one variable, and this is the likelihood that each of those options happens for this variable. So there's only one variable.
We always put it in that table. It's only one.
That's how I do it. The first list, I put the possible values. The second list, I do the likelihood that they're going to happen.
Which
Edgar?
number is it?
Oh, no.
Okay.
I'm talking about the frequency is always in.
Right now, I just want the mean. And your calculator will say X bar.
The X bar,
Yep,
so it would be 4.5.
correct. Now, that's not what the question is asking, but you need this piece of information to answer the question. It says, what's the likelihood that the number of times that Luke will hit the inner ring of the target out of 5 attempts is less than 4.5? Well, look at these numbers up here. Which of these numbers are less than 4.5?
Oh, wait.
All of them except 5. Right? Do you agree? All of those numbers are less than 4.5 except for 5. Okay? Well, what's the likelihood that he hits it in 0 tries? This number, right? 1 try? 2 tries? 3 tries? 4 tries? So some students will add those numbers together. Me personally, I just did 1 minus that number. And that's the answer. Yes, because it's not this. So you guys know complement, subtract it from 1. So the likelihood that he'll hit it in less than 4.5 times is the probability, 1 minus the probability he hits it on the 5th time. So what is 1 minus 0.59049? I believe it's going to be A. Yes, sir, question?
Why did you? Oh, sorry.
Okay.
Why did you switch that?
What did I switch what?
Like the .59
Uh-huh.
is less than 4.5.
Are you talking about this right here?
You switching the decimal to 4.5.
Switching the decimal. What did I switch? I'm sorry.
No, he subtracted 1 minus 0.
No, I mean like 5. Why isn't it 5?
Well, because it says less than the mean, so 5 is not less than 4.5. So it's all of the possible outcomes that are less than this number.
Oh, we're talking about attempts.
Yeah,
Okay,
tenths.
I was looking at the bottom of it.
Oh, never mind.
Yeah.
You did this one, subtracted 1 from 5.
I did this from 1. Yeah.
So you didn't really need any of the information.
So you didn't even have to go 4.5.
Well, because sorry to answer your question real quick, because I would have if they had only given me that, but they gave me the whole thing. So, go ahead.
So you didn't have the 4.5 attempt?
You did have to find the 4.5 attempts because I had to find the mean of this random variable. So we expect him to take 4.5 attempts to hit the inner target.
This one would be chapter 15, right?
This one is chapter. When did we do expected value? Was it 16? I think it was 16. You're right. Yeah, sure. Leave your phone. Yeah, it was 16. Probability models right here. 16. Guys, if this is not like important, I'll just sit down. I have plenty of work to do.
No, it's
There's
important.
just a lot of talking going on. I mean, don't apologize. Just fix it. Okay, great. And do you listen to your father? Do you listen to your father? You should listen to your father. You only get 1. Okay? All right. I'm going to number 5.
Yeah, I don't know. What can you see if y'all can get one right now? Because I got the same thing.
Can I do it at the end?
Yeah.
Okay.
Sorry.
I'm not mad. Just disappointed. That was a father thing, right? Right? You're fine. I'm mad. Okay. This problem, oh man, this problem threw me for a fun loop for a little while.
Eating you? No way.
Well, I was going down and doing way too much work. And I realized, oh, I can do this without doing that much work. So we have a random variable s. And this is why this question is challenging, is because the random variable s is actually two of them added together. All right, it is. Yes, I know. It says random variable s represents the sum of the points earned. So really, s is, I'm just going to make it x plus x. And I just use x. That's fine. Use whatever letter you want. Okay? So this x is rolling the dice one time. Okay? The second x is rolling it again. Okay? And it tells me that they're independent, which makes sense. And it wants me to pick what is the probability model for S. Well, my first thought was, okay, if that's the case, and I'm adding these points together, what are, because you guys see the first row, how they're different? I can eliminate some of these answers by just asking myself, what are the possible numbers I could get? Could I roll a 1 and then a 1? Yes. Could I roll a 3 and then a 3? Could I roll a 1 and then a 3? So is 0 likely possible, or is 0 a number I could get? Yes. 0 plus 0 is 0. Because, here you go, Charles. I roll a 1, I get 0 points. I roll a 3, I get 0 points.
Oh, okay.
0 plus 0 is 0. Got it now? Gotcha. Can I get 1?
Yes.
Yeah, like 1 and a 2. So I can get a 1. So immediately I crossed out B and C. Because do you see how they don't have 1 as a possible value here? You have to have, you can get 1, so that's why I've crossed those out.
Oh, okay.
Okay? Now, could I get 2?
Yeah.
Right? 2 2s, very good. Or a 1 and a 4, or a 4 and a 1, or exactly, you got it, so I can get 2. Could I get 3?
Yes.
A 2 and a 4? So now I can cross out A, because A doesn't have the 3.
Okay.
All right, and then can I get 4?
Yes.
Yep, I can roll back-to-back 4s. Okay, so now I know I haven't really done that much work, but I eliminated almost all of them.
Let's go.
Now I got 50 feet. Let's stay, please. Now, I was starting to actually calculate them. And I was like, I feel like there's a quick way to do this. Well, I'll let you know on the flip side. If it's Mr. Rispin, I'm going to flip out.
You can tell by. Never mind.
It's Mr. Render. Okay, sure. Thanks.
Bye.
Catherine, they want to see you in the office. It'll be quick. If it's going to be quick, why not call me at 4 o'clock?
Oh,
Then I
yeah.
have to come on.
Wow. Well, I'd like to be here. I don't want to be here. But right, I mean, like, why not call 4 o'clock and I'll just send them with their stuff? It's going to be quick. It just doesn't make any sense. It just makes me feel like what I'm doing is not important. But as Mr. Risman said, his stuff is more important. Okay. Are we good on eliminating A, B, and C? So I started trying to calculate all these probabilities. I was like, I feel like there's an easier way. And so I realized there is. What is the expected value for just one roll? Okay? So okay, I'm going to do it up there. So what's the probability I land on a 1? No, what's the probability I roll a 1? Very good. So how'd you get that?
1 4.
There's 4 numbers.
4 numbers, 1.
Okay. I'm just asking. It's all good. I'm not like mad. Okay. You got it, so I want everyone to see how you got it. Okay. And so when I roll a 1, I have a 1 out of 4 chance of doing that. How many points do I get?
0.
0. So, okay. Nothing. What about the likelihood of me rolling a 2? Same thing. But how many points do I get when I roll a 2? I get 1 point. Okay, I'm going to keep going. If I roll a 3, that's going to be a 1 out of 4 chance. How many points do I get for a 3? 0. And then finally, very good, because when I roll a 4, I get 2 points. If you do that, the only ones that end up mattering are the second piece and the fourth piece. So you get 1/4 plus 2/4, or 0.75, 3/4. So my point value for one roll that I expect to get is 0.75 points. But how many rolls am I doing? How many rolls am I doing? 2 rolls, right? So I roll it, I expect to get 0.75. I roll it, I expect to get 0.75. So what is my expected value for S? Very good, it's 1.5. You add them together. And you're allowed to do that for means. Does it ask for the standard deviation? No, because then I'd be doing a lot of different stuff. Okay, you still with me? So now I thought, okay, well, ready? If it needs to be this number, and if I multiply all of these and then add them, and I get 1.5, I know that's the answer. No, that wouldn't. So, no, I use my calculator to find the expected value for S for each of these, and only one of them gave me this number, which is what I'm expecting.
So you added all the probabilities together?
No, I multiplied the likelihood of getting 0 points times its probability, right? I found the expected value. I found this a different way using the chart, and it needs to match what I already calculated, 1.5. So again, I know that wasn't simple, but it was much simpler than actually creating the chart. So, what is it? You got it? It's E? D is too low? Well, I already threw in the answers, so I already forgot. Oh, your ref's face says no. I added 0.75 and 0.75. Yeah. Sure.
Because where it comes from, as
No, I got the answer is D, man. Yeah, D. D's the answer. This one is over 1.5. This one's over. I think it's like 1.7 something. You got D? Okay. For D? Are you multiplying 1 times 0.25 plus 2 times 0.3125 plus 3 times 0.125 plus 4 times 0.064? Okay, I'm going to keep going. All right, maybe we'll feel better about this one. I think we will. Okay, we have a distribution of colors. It says you draw a candy out of the bag, and you look at it, and you write down the color. But then it says you put it back. Gross. But you put it back. Okay? You see how it says with replacement? That means you put it back in the bag. So do any of these numbers change after I pick one up? No, because I'm putting it back. Okay? So it says, what's the likelihood that I have the same color? So that's brown and brown. That's red and red. Yellow. You see where I'm going with this?
Can I put the M's or upside down?
Sure. He's talking about this symbol.
Oh, you?
No.
Oh, no, that's
Okay. When you see the word and, you should be thinking multiply. But you have to ask yourself, are these independent? And why are they independent? No. If you pick it out and eat it, they're not independent. But if you pick it out and put it back in, they're independent. I know, Jarvis, but I want to make sure I work. All right. So if you multiply 0.3 times 0.3, you get 0.09. If you multiply 0.2 times 0.2, you get 0.04. You see where I'm going with this? And if you add those together, you get the answer.
Wait, so 0.1 equals 0.0?
Correct. 1/10 times 1/10 is 1/100.
Just do 9 and the 1 and then the 4.
What is it?
It's B.
It's B. 0.22. It's going to be tight. We need to really focus up here. Okay, to finish. Okay. Now, if you read this one over the weekend, all right, I know you guys, I will tell you, this is the hardest test you're going to take all year. Okay, it's the worst you're going to do on a test all year. It's okay though. It just means the curve is going to be better. When you read this, if you're not thinking tree diagram, then you got problems. When you read this, your brain needs to think tree diagram. It says, wait for it, there is a 30% chance that your flight is delayed because of ice. You might not know what that means, but that happens. All right? So there's a 70% chance that it's not delayed by ice. Then it says, if your flight is delayed because of the ice, there's a 10% chance it's also delayed by a mechanical issue. Oh, the dreaded mechanical issues. All right, so that means there's 0.9 that it's not. If your flight is not delayed because of icy weather, there still is a 5% chance that it's delayed because of mechanical issue. So there's a 0.95% chance, 0.95 chance that it's not going to be delayed. So you guys remember when we did tree diagrams, as you go across the branches, you must multiply. So this is ice delay and mechanical delay. This one is ice delay and no mechanical delay. This one is no ice delay and mechanical delay. And this one is no ice delay and no mechanical delay. And start multiplying. Is that right? I think that's right. Yes. Okay. That one's going to be tiny. This one's going to be massive. Oops. Okay. So you notice I haven't actually even read the question yet. Right, what I'm solving for? I mean, I don't know if it's smart. I mean, I know I've done thousands of these. I know it's going to be a tree diagram. A professional, yes, I am. I'm a licensed teacher, so yes, I'm professional. Okay, I get paid for my services. If one flight is selected at random from the airport in January, what's the likelihood that the flight selected has at least one of the two types of delays? So it either has icy and mechanical problems, or icy and not mechanical problems, or not icy problems but mechanical problems. The only one up there that doesn't have that is the last one. This one doesn't have any problems. Perfect flight. Well, it could have other problems, but it doesn't have these problems. So really, all I did was either add those three together, or you can take this and subtract it from 1.
All of that has to equal 1.
Exactly. All of it has to equal 1. So again, that's one of those, and you know it's going to happen on the test. When you read the problem, you got to be thinking, oh man, is this a tree diagram problem? Jarvis, you know, like, I get it, okay?
That's how I talk about it. Oh, man.
Come on, Douglas, it's a tree diagram. Okay. Do I need to say it again? It's the second time? Like, I got plenty of things I could do. We're slapping each other. Like, what are we doing? He's checking you? I mean, this isn't hockey. Why are we checking each other? Okay. Number 8. We have a box. And it contains 10 tags, numbered 1 through 10. Okay? I have another box that has numbers 20 through 27. Okay? Well, let's start with the first box. I open the box. I pull out a tag. What's the likelihood that it's a 1? 10%. Very good. 1 out of 10. So 0.1. You'll notice all of them have a 1 out of 10 chance of happening. What about the second box? I pull out one of these. Not 1, 7. I believe there's 8 of them. There's 8 of them, which is 0.125. 0.125, please. Just if you use 13, you'll get it wrong. If you put 12, you also get it wrong. That's why it's 1, 2, and 5. Now, I'm hoping at this point, when it says in the problem, what's the expected value for the sum of the numbers that you take out of these boxes? Well, find the expected value for the first box, and then you can add them together. So you're going to multiply 1 times 0.1, 2 times 0.1, 3 times, all those multiply and then add them together. So what's
3, 6, 10, 15, 6, 21, 28,
Are you
36.
adding it together?
Yeah.
Sorry.
5, 6, 5.
Oh, well, remember they're all 1/10, so it's 5.5. Yeah, not 55. Just,
I mean, like 5.
thank you for helping. Yes, I appreciate you. No, he helped though. It's 5.5. Let's see if you can do it for this one.
Let's go.
Times 20. Never mind.
You can use the calculator, guys, and I'm not expecting you to do this mentally.
Well, like the top one is easy.
Yes, obviously, it's got 1/10, much easier.
Yeah.
You're just going to let me write it? Okay.
Test the
I believe it's 23.5.
All right. Add the bad boys together. Sorry. What are they?
Well, that one should be a little easier. It's 29. Okay. Let's move on to the last two.
Yeah, how did you get 55? Oh, 5.5.
I didn't get 55. I did 1 times 0.1 plus 2 times 0.1 plus 3 times 0.1 plus 4 times 0.1 all the way. Same thing with 23.5. 20 times 0.125 plus 21 times 0.125. It's called the expected value. You take the numbers that could happen times the likelihood that they'll happen, and then add them up. That's what you expect to happen. All right, number 9. This one, I think we'll be okay here. Number 9, it says, what is the standard deviation? So you asked this, how do you know I've got standard deviation of a random variable? I should be thinking variances add. Right here, man, it's a perfect spot. It's a perfect length, I promise. All right, so variances add, what? Of course, right? Or get parental consent. So, variances add. Now, this is where they're trying to mess you up. Because what did they give you? They gave you the variance. So you're going to add 35 over 12 plus 35 over 12, right? I know it says first minus second, guys, but I don't care because the variance is add. All right? And then what am I going to do with that? I'm going to take the square root and look at that. That's C.
Oh, they try to trick you on B.
They are trying to trick you on B. I'm sorry? Okay. Okay, so Bianca's like, wait, hold on, because before we squared it, if they had given me standard deviation of x, then I would have squared them first before adding it. Because remember, it's variance is add, but that's how they're trying to trick you. They give you the variance on this one.
Why did you repeat it though? Like, why wouldn't you just be A? Because
Remember, I went through this. The random variable y and x, there's 2 of them. And then once you subtract them, all right? But we know that you always add the variances to get the standard deviation. So they want you to find the standard deviation of x minus y. And you got to add the variances. Boom, C. Hopefully that one is quicker. That was a quick one. Okay, let's do one more. Do you even know the things you're writing?
yeah.
Yeah? Okay, good. So, you can always watch the video later, right, Edgar? What video did you watch? All right. Okay, so we have 4 drivers. 4 drivers. And guys, this is an example of a Bernoulli trial. You have a success or a failure, speeding or not speeding. You have a constant probability of success. I know it's weird, but probability of success is 0.4 for speeding. Imagine just listening to this question. Wouldn't that be nice? And the third thing is independent trials. Do we think one motorist speeding is going to affect the other motorists?
Yes.
I agree. I agree. All right. So, I mean, we're violating it, but, you got to answer the question. So here we go. Probability that we have at least one motorist driving 5 miles an hour or more over the speed limit. Okay? Now, you guys know that when I see the words at least, what do? See the word at least.
You do it for all of them.
I do the complement.
Oh.
So if at least 1 out of 4 motorists, that's 1 out of 4, 2 out of 4, 3 out of 4, or all 4 motorists are speeding, what's the complement? 0 out of 4. So let's find the probability that it's 0 out of 4. All right, so that means the first car I look at, are they going 5 miles an hour or more over the speed limit?
No.
No. So what am I going to use for my probability?
0.6.
Very good, Catherine. It's amazing what happens when you listen. Okay, now the next car comes by. They're not going more than 5 miles an hour over the speed limit. What do I write? 0.6. You're going to see how many of those? There's 4 of them. So what's 0.6 to the 4th power? It's actually a small number, right? 1296, right? I'm not going to round yet, your ref, because I want to wait till the very end. That's not what it asks for. It doesn't ask for what's the likelihood that none of them are going more than 5 miles an hour. It says at least 1. So you must do 1 minus 0.1296. Boom, D. You did it. Wow, is right.
Every answer that I